In our exploration of the cosmos, we've observed how incomprehensible quantities of matter will behave when they're spread across an incomprehensible volume. All of this matter, which is mostly hydrogen and a little bit of helium, but there's some other stuff in there too, precipitated out from the Big Bang. And as space expanded and matter was splattered across the universe, points of higher density began to form. Little conglomerations and clusters and clumps of matter, spinning around each other in their gravitational entanglements, consolidated out from the void to give birth to galaxies, each of them composed of countless droplets, and each droplet is a massive, raging inferno of nuclear plasma. As we've studied these nuclear infernos, we've noticed patterns and relationships. Natural forces and the raw matter of the universe will create stars in certain ways, and stars have life cycles and stages of growth and death. Stars have 1,000 other variables, like luminosity, temperature, and radiation output, which all affect the even smaller conglomerations of matter that orbit them, called planets, and the even smaller conglomerations of matter that creep and crawl across the surface of those planets, called life forms or organisms. A particular type of star is a red dwarf star. These are small, dim, and relatively cold. When exoplanets were first discovered, especially exoplanets around red dwarf stars, it was speculated that red dwarf star systems could be stable places for human colonists. After all, the red dwarf stage of a star's life is very long-lived, so the local planets wouldn't have to worry about the star expanding and burning them up. Incidentally, this is the future for our star, which will expand and burn up the Earth sometime around 600 million to a billion years in the future. Unfortunately, it's also known that red dwarf stars are not particularly calm. They emit a relatively high amount of UV radiation, and this has led many to think that planets orbiting a red dwarf star would be sterilized and lifeless because of the high UV radiation output from the red dwarf. But a new study, published in the monthly notices of the Royal Astronomical Society, suggests that this line of thinking may not actually be all that accurate. The heavy UV radiation of a red dwarf star may not necessarily be a bad thing for life. In their paper, the researchers point out that the surface conditions of exoplanets orbiting red dwarf stars, like the density, composition, and stability of their atmospheres, are unknown. To address this, they sampled 4 of the closest exoplanets that orbit in the habitable zone of their parent red dwarf star. These exoplanets are TRAPPIST-1e, Proxima b, Ross 128b, and LHS 1140b. Because we still don't know precisely what the atmospheres are like on these planets, the researchers applied many different atmospheric models to each exoplanet, and calculated the surface conditions under their specific parent star. I should point out that these different red dwarf stars, be they Proxima Centauri, Ross 128, TRAPPIST-1, or LHS 1140, all of these red dwarf stars give off slightly different wavelengths of UV radiation in slightly different quantities, and so each star will have a slightly different downstream effect on organic chemistry. In one model, the planets were given Earth-like atmospheres, dense with nitrogen and oxygen. In another model, the planets were given atmospheres that were very high in CO2 and had no oxygen. And another model had so-called eroded atmospheres, which is where the atmosphere is thin and wispy because it's been broken down by radiation and/or blasted away by the solar wind. These are just a fraction of the models that they used, and the results from their modeling and analysis are pretty surprising. The researchers say, quote, "Even for planet models with eroded and anoxic atmospheres, surface UV radiation remains below early Earth levels, even during flares," unquote. Essentially, the UV radiation from the red dwarf stars shouldn't be too much of a burden on life getting started at least. They mention the early Earth, and that's a critical detail. About 4 billion years ago, when life first got going on Earth and Earth was young and newly formed, the Sun was at a different stage in its own life cycle, and it was putting off far more UV radiation than it does today. As we all know, life perpetuated itself and thrived on this early Earth, even if it was under the radioactive glare of a younger yellow star. These red dwarf stars just aren't as dangerous to life under any kind of atmosphere, even an eroded atmosphere, and even during a flare-up where UV radiation output is at its most intense. Okay, so the study found that the threat of red dwarf UV radiation is mostly overblown, as we know that life has survived even worse here on Earth. The earliest life forms on Earth were exposed to even more radiation here, and yet they still survived and proliferated and eventually created complex life. This strongly suggests that these red dwarf orbiting exoplanets can safely undergo abiogenesis and host their own life forms and their own evolving lineages of life. This is where I want to step in and do a little speculation of my own. We know that UV radiation can mutate genes. We know that a lot of mutations can be deadly, but a more moderate mutation load can actually be good for life. A more moderate mutation load can spur the generation of mutations through which natural selection can act, to produce a diversity of species that are quite varied morphologically, physiologically, and in their life strategy to adapt to a wide variety of ecological niches. Perhaps life on Earth spent more than 2 billion years as single-celled microbes because the radiation environment of the early Earth was too intense, and so larger, more complex genomes and subsequent body forms weren't possible until the star calmed down a bit and stopped giving off so much radiation. If this is the case, then the more moderate radiation load from a red dwarf star could possibly give rise to complex life faster. However, where our star slowly lowered its radiation output as it aged, to the point where today the star doesn't give off that much radiation at all and we can comfortably go outside and live our lives in the sunlight, recall that the red dwarf star can be very long-lived. A red dwarf star will be giving off its high radiation output for a long time. This means that any resident life on local planets could evolve to become more complex faster, say 500,000 years to complexity instead of 2 billion, but it might also experience a lower complexity ceiling, or a more restrictive upper bound on their growth and complexity. As these alien organisms grow larger, they're exposed to more radiation, by nature of having a larger surface area, which also means a higher mutation load, and a higher risk of cancers and death. However, it's also possible that any life to evolve in such a red dwarf environment would become used to the radiation or evolve adequate defenses against it, which would make this whole thing a non-issue. In either case, it makes for some pretty thought-provoking speculation. Now, coming back from the theoretical to talk about something a little more grounded in fact and known reality, as far as humans are concerned, any colony that we put on an exoplanet orbiting a red dwarf star will still have to have radiation shielding, even on planets with nice thick atmospheres. The higher UV output from the red dwarf star is still relatively dangerous to the human organism, to the human being, and so any human colonists that we send to these red dwarf planets will have to take these precautions, because the UV radiation is higher than what we've evolved in the most recent 6 million years of life on Earth. Because the most recent 6 million years of life on Earth, our star has been relatively calm, and its UV radiation output hasn't been too extreme. This is the ecological and planetary environment in which we evolved, and so if we leave this environment to go to another planetary environment, like that of a planet that's getting pummeled by the UV radiation of their host red dwarf star, the human colonists going to that planet are going to be in a tough spot. They're going to have to take these precautions to protect themselves from radiation exposure. The universe really is an exciting and interesting place, full of opportunities and potential for discovery and colonization. But it's also dark and full of dangers.